Next problem, reframe not required and shifting the origin type, right? So the following are the number of mistakes made in 5 successive days of 4 technicians working in photographic laboratory. Test at 1% level of significance whether the differences among the sample means can be attributed to chance. The given data, total number of items n is equal to 20, number of technicians r is equal to 4, and number of errors of each technician ci all are equal, c1 equal to c2 equal to c3 equal to c4, which is equal to 5. Defining hypothesis, null hypothesis h0, there is no significant difference in the mean error committed by the 4 technicians. Alternate, so there is significant difference in the mean error committed by 4 technicians. Shift the data to the origin 10. So you have to subtract 10 from each number of the given data, right? So 6 minus 10, 14 minus 10, 10 minus 10, 8 minus 10, 11 minus 10, first technician. So similarly you have to for the second, third and fourth. So you will get the new data, right? You have to use that one, right? So first calculation for ANOVA table. So write technicians 1, 2, 3, 4, then errors 1, 2, 3, 4, 5. So revised data minus 4, 4, 0, minus 2, minus 1, 4, minus 1, 2, 0, 4, 0, 2, minus 3, 5, 1, minus 1, 2, minus 2, 0, 1. Then first find the row total. So first R1, row 1 total minus 1, row 2 total 9, row 3 total 5, row 4 total 0. Just add the numbers in that row, right? First row, second row, third row. So sum of the row totals. So that is grand total. G is equal to summation Ri, which is equal to 13. Next you have to find Ra square by Ca. So R1 square by C1. So minus 1 square by 5, 0.2. Then 9 square by 5, 16.2. Then 5 square by 5, 5. 0 square, 0. So sum of Ri square by Ci, that is equal to 21.4. Next sum of squares, summation of xi square. So square each number in the first row and add up all the numbers. So minus 4 square plus 4 square, 0 square, minus 2 square, plus minus 1 square. So adding all these things you will get 37. Similarly for the second row, third row 39 and fourth row 10. So adding all the sum of squares you will get sum of squares, that is equal to 123. Next correction factor, g square by n. So 13 square by 20, that is equal to 8.45. Next total sum of square formula is sum of squares, right, minus CF, correction factor. So 123 minus 8.45, 114.55. Sum of square between the samples BSS, summation Ri square by Ci minus Cf, that is equal to 21.4 minus 8.45, that is equal to 12.95. Sum of squares within sample WSS, so TSS minus BSS, 114.55 minus 12.95, that is equal to 101.6. Next ANOVA table, source of variation between sample and within sample, sum of squares BSS between the sample 12.95, within the sample 101.6. Next degrees of freedom, so V1 R minus 1, that is 4 minus 1, that is equal to 3, and V2 N minus R, that is 20 minus 4, that is equal to 16. Next mean sum of squares. Mean sum of squares between sample BSS by V1 12.95 by 3, that is equal to 4.32, and means square, that is within sample WSS by V2 101.6 by 16, 6.35. Here 6.35 is greater than 4.32. So in the F formula, first you have to write MWSS on the numerator and in the denominator MBSS. So F ratio MWSS by MBSS. So that is equal to 6.35 by 4.32, that is equal to 1.47. So calculated value of F is 1.47. Next we have to find the tabulated value. Here degrees of freedom is first highest and then lowest. Highest comma lowest. See here highest is V2, right? That is 6.35. So related degrees of freedom, right? V2 comma V1. So 20 comma 3. So at 1% level, degrees of freedom 20 comma 3 from F table, tabulated value is 5.29. So calculated value 1.47 is less than the tabulated value 5.29. Therefore the H0 null hypothesis is accepted. Therefore there is no significant difference in the mean error committed by the 4 technicians. Thanks.